So I have been working in the, network industry for more than 12, 13 years from now. And also I've been training from.
Sorry, by mistake I done. I put you on mute.
Oh, okay. Okay. No problem. So I know we are here for the NRC class today. So we are going to learn a part of CCNP, which is known as NRC. And you should be knowing the code for NRC as well, the recent one.
Hello.
I'll let you know all. I think who is this?
Guys, be on mute if in case if you don't have any questions and all. Yeah, go ahead.
Yeah. So before starting with the class, I just want to know about the, introduction or brief introduction or maybe some background of you guys so that, so that it'll be helpful for me to, train accordingly. So as I said, so I am from routing and switching industry. So I usually do routing and switching from the, all my experience goes in routing and switching SD-WAN. So any of you guys, I'm interested to know if any of you guys are, already CCNA or, have already learned CCNP earlier, what to revise.
Hi
Can you guys?
Rahul, this side
Yep.
Shivaguru. Yeah,
Hey,
myself
hi.
already completed CCNA long back,
Okay.
5 years back.
Okay.
After that, I keep on working on, mostly router switches and servers, IT infra, complete IT infra equipment. Depends on
Oh,
the customer request. We are in service field. Okay,
got
ticket
it.
basis, we are working on that.
Okay.
I willing to learn CCNP, but keep on. I'm now only I engaged with you guys finally. Uh, it should be NRC and NCore, right? We are starting NRC today. So
That's right.
my concern is straightly we are going NRC. Any impact like NCore is the core network we have to learn first, right? That's what I think.
No. So if you look at the syllabus,
Yeah,
NRC is the one which actually gets you into the depth of the routing knowledge first.
correct,
Right?
correct.
NRC includes all the routing protocols. So basically, whatever you have learned about the routing protocols in CCNA, it takes you more deeper in NRC. So once you know about the, you can go to the NCore. With that knowledge, you can understand the NCore.
Easily.
Yeah, easily, quite easily. So basically, NRC and NCore, they are all the same. But I would say this has been good for you that you are learning NRC first because
Okay.
NRC. If somebody asks me, I would suggest NRC first as well.
Okay, okay. Then good. So whatever protocols we learned there, that will be deeply we are understanding here, right? In CCNA.
That's right. That's right. So it is just in depth of knowledge whatever you have learned in CCNA.
Okay, okay. Understand. Yeah, for me, totally I have 10 years of IT experience. Basically,
Awesome.
I'm in the customer support field, handling, varieties of customer request.
Awesome. Okay.
That's what. Myself and Kuris will be in the same team. Okay. He's also there on the call. Kuris Khan.
Yeah.
He's also
Thank you.
completed
Thank you.
CCNA. Yeah. This is my, that's it. Yeah.
Awesome. Next, anybody else?
Hi, Rahul. This is Yuvraj.
Hello.
Are you able to hear me?
Yes, I'm able to hear you. Go ahead.
Yeah. So, hi, this is Yuvraj. I had done with my CCA from and followed to fire as well as from networking. I
Uh-huh.
am working in a network industry from since like 4 years, more than 4 years.
Okay.
So yeah. So now I'm working in a network industry. That's all.
Have you been through CCNA and CCNP earlier?
No, I done with my CCA in last year, February. Yeah.
CCNA.
Yeah.
Okay.
So I want to just learn more deeply like BGP, OSPF, EIGRP because nowadays we use that protocol apart from that MPLS. So that's
Correct. Correct.
yeah.
Correct. All right. So I think yes, we'll be able to help you with that. Not a problem. Thank you, Raj.
Hello.
Yes.
Hello. Yeah. Hi, Rahul sir. How are you?
I'm good. I'm good. Thanks for asking. How are you?
Yeah, I'm good. So this is Deepak. Actually, I have started my career since 2014 around.
Mm-hmm.
And before I was as a transmission engineer in ZTE and Huawei. And after that, I moved to subsea cable landing station engineer, CLS engineer. So
Okay.
currently I'm working on maintaining the CLS, subsea fiber optic cable. But like right now, like what I have seen that in the market, that if you have the knowledge of networking like CCNA, CCNP, and CCIE, so it's very good career opportunities in the future, because if you have the transmission and the networking skills, so that's why I want to enhance my skills. And I have completed 2 months before CCNA from networkings. Now I'm just moving to CCNP to learn about the networking is how to maintain network infrastructures and how ISP is working. So that's my target.
Got you. Thank you so much. So I guess if I go on, like, just give me 1 minute here, guys. Yeah. Okay. Well, thank you, Deepak. But let's do one thing. So I think we are more than 40 people. So I think the introduction of everyone will
Yes, yes.
take
It's going to
more
be a
time.
more than 2 hours. So
So
let's continue on
basically,
focus.
yeah, that's
Yeah,
right. So
focus on focus.
basically, I just want to know if there is anyone who has already learned CCNA.
Yes, already. Just we have
Oh,
already. Just
okay.
I'm already
Yes,
learned.
no.
Awesome.
But
What
like
about what
5
about
years.
CCNP?
Yes, Rahul, I have done NCORE. In
Okay.
last two years back, I had did NCORE certification, and NRC I had to take it, so that's why I joined this batch. Yeah.
Awesome. Okay. Okay. Anybody else with CCNP?
Yes, yes.
Awesome. Okay. So that's good. So if I think so many people are from CCNA background. I think almost everyone are with CCNA background. So I think it's a good learning for you guys. Having said that, let's move on to a bit of syllabus. So in this batch, we will be learning about the NRC, and we're focusing on this exam code, okay, which is 300, 410. Okay. So the topics that you should have already been, familiar with the topics, exam topics that we have. We have routing fundamentals, then we have about EIGRP, then we have about OSPF, then BGP, then we are talking about VPN, and then we are talking about the troubleshooting services. These are the 5 main or 6 main. Sorry, guys, be on mute. So these are the 6 main topics that we have in the NRC that we're going to study now, right? So before introducing you guys to NRC, I just want to give you a basic introduction of our networks. Till now, since we are concentrating on NRC, till now, whatever you would have learned in CCNA, right?
Yeah.
Please be on mute, guys. Till now, in CCNA, you have seen that if you have any loopback interface, let's say loopback 0, which is 10.0.0.1 or 10.0.0.2, which is the second loopback, right? And here you have another loopback, 10, 11.0.0.1, 11.0.0.2, 11.0.0.3. These are examples. Don't worry about this. How does R2, that is the router 2, know about the networks which are connected to R1? How does R2 know about it? Also, in the same way, how does R1 know the networks which are connected to R2? How do they know? That is why we introduced some protocols, or in earlier days, they introduced some protocols which are known as routing protocols, right? They introduced something known as routing protocols, through the help of which we are able to get this information exchanged from one router to another, right? We already learned about this and already you have went through this in CCNA about many protocols. That is, let's say EIGRP, OSPF, BGP, right? Coming back to that, guys, you're able to see my screen, right?
Yep.
So
Yes.
in CCNP, there is no BGP, right?
I'll tell you about it. That is also a routing protocol, right? So when you talk about routing protocols, before what we were doing, right? In the earlier days, when you had two routers, you know that before we didn't have so much of devices on internet, right? We just had one or two devices, or maybe in a company, you had around maybe 5 routers or maybe 4 routers. Whatever was connected this part, loopback 0, loopback 1, loopback 2, or any other router connected here, okay? 10 dot network, 10.1, this is 10.2, right? Whatever loopback was connected, the administrator, that is people like you and me, administrator is nobody other than me and you. What we used to do, we used to manually go to this router, okay? And there is something known as command console, through which a router can be configured, right? So we used to get inside the router and we used to manually enter the commands, saying what? If you want me to tell you in layman terms, that is simple terms, I was just going to this guy here and saying through the commands that, hey man, these networks are connected. And if you want to go to those networks, first you have to go to (1.1). Okay, first you have to reach to 1.1. That is your next hop, because you are on 1.1. Sorry, you are on 1.2, which is here. I have configured this interface as 1.2. If you want to know about these networks, please go to 1.1. That is what I used to tell him through the commands, right? So basically, I used to go to configure terminal and I would say IP route. That is, if you want to know any IP address, then you have to route to the next destination, right? If you want to know IP route, this is the keyword. If you want to know about 10.0.0.1 network, and the subnet mask is 255.255.255.0, whatever, mention the subnet mask here, then what is the destination or next hop that you have to go to? That will be written in the next 168.1.1. Administrator used to go In the office with just 2 routers, you used to simply write IP route 10.0.0.1. If you want to go to 10.0.0.1 or 10.0.0.2 or 10.0.0.3, just go to the next hop, 192.168.1.1. Then this router would make a note of it in the routing table, right? As in when you give an IP route statement, the routing table will be updated. You guys know that already, right? On this router, on R1, how will be the routing table? It will have all the connected networks in the routing table. All the connected networks will be in the routing table. Not only that, 192.168.1.0 network /24 also will be in the routing table of R1. Of R2, the routing table of R2, what will be there? 192.168.1.0 network. This is routing table of R2. Because why? Why this will be in the routing table? If anybody's question is that, then let me tell you, router 1 or router 2, or in fact, any router, right? Any router in its routing table will already have directly connected networks. Now, if you connect, for example, this interface to 192.168.1.1, this is directly connected, like a person with his own hand, right? If you are holding someone with your hand, you will know that your right hand or left hand, whichever is holding the next person, you will know it, right? Similarly, this is the router interface. It will know its own interface, what IP address it is connected to, right? As well as loop, it will know. Now, why am I teaching you all this? Because I just want to make sure that you know how the routing happens. If you know how the routing happens, then we can talk about the routing protocol, right? I can go deep because many of you have done CCNA, but it has taken some long time to reach the next course like NRC or NCore, right? So you might have forgotten little concepts. So I'm just trying to fill the gap. Okay. So this is how the routing used to happen. So already the connected networks will be in the routing table. Here also, R2 is directly connected. Its interface is connected to 1.2. So it will have. Now, this is the manual route added by the administrator. Okay, I agree. Administrator added these routes. But what if there are 100 more routers like this? Because now the company size is growing, right? Now we are being, we have like 1,000 or 1,500 employees in one facility, in one building. So imagine the administrator's task to go to each and every router and add some commands like this on every router. It's very difficult, right? So before, when the routing were introduced, we only one type of routing that is known as static route. So what is a static route? We just learned it. Administrator manually gets into the router, adds an IP route command in the command line of the router. That is the static route. Now, what is a dynamic route? Later, why did they introduce dynamic route? Whenever you try to think in a way, if you want to think about any networking concepts, just think about why. Why did they invent this? Then you will remember it. Then you will be able to remember it very well. Okay. Now, why did they introduce dynamic routing? Because the routers started growing, right? The routers started growing in number. We cannot add static route. That is, the administrator cannot go ahead and add static route in all the 1,000 routers. It will be very difficult task for him. So the concept of dynamic routing came into existence. Sir, now what is this dynamic routing? You already know this. RIP, EIGRP, OSPF, ISIS. These are your dynamic routing protocols, right? What is the advantage of dynamic routing versus static routing? In dynamic routing, we don't have to do anything. We just have to advertise this interface, that is this one, this interface, and any interface connected this side also, or all the interfaces on a router. We just have to advertise these interface. The router automatically becomes their neighbors and they exchange the routing information. That is the routing table with one another. Now, there is also some condition. Simply it does not exchange. It should also satisfy some condition. Now, what is the condition? Now, when you have two routers, let's say you have two routers. Now, to enable dynamic routing protocols like EIGRP, let's say EIGRP or RIP or OSPF, because these are the EIGRP and OSPF are the ones which are used widely nowadays. All others have been, faded out. Now, I want to run dynamic protocol, RIP, on this dynamic routing protocol. How do I do it? Let's say the IP address of this interface 192.168.1.1 and this is 192.168.1.2. I have to go to this router. I have to start the process. How do you start a dynamic routing protocol? Just say configure terminal and say router RIP, just name of the protocol. If you just write router and the name of the protocol, that the protocol is started, protocol is initiated. Then advertise the network. How do you advertise? I just say, okay, I just say network 192.168.1.1 on this end. Same way, I say network 92.168.1.2 on this end. Here also I do a configure T. Now I want you to see the difference, right? Here also I'll say router RIP. Now what is happening is, whenever dynamic routing protocols to exchange information, first of all, you have to see that they are in the same network. And 1.2 or 1.1 and 1.10. That also is fine. But They should be in the same network. What if they are in the different network? This is 192.168, this is 172.16. No, they would not be becoming neighbors. First rule of any dynamic routing protocol, they will form neighborship. First, they will form neighborship with each other. Only then they will exchange routing information. So any dynamic routing protocol, what is the method of exchanging information? There is a procedure. What is that? The first one is they will form neighborship. What is neighborship? They will send some information to each other first and find out if they are neighbor of each other. If the neighborship is established, then they will exchange the routing table between them. Okay. This is the way how they exchange routing table. This is how the dynamic routing protocols interact with the routers. Do you have any doubts till now or any confusions on this part, guys?
No, Rahul.
No,
No.
Rahul. No, Rahul. You can go
Okay,
ahead.
you're good with this, right?
Yes.
Awesome.
Yeah.
Awesome. Then I can proceed forward. So I guess nobody has any doubts. So let's proceed forward. Now, let's move into routing concepts, right? Routing concept in the sense in NRC, the first syllabus or the first chapter that we have is routing fundamentals, right? In routing fundamentals, we can learn what is summarization, what is redistribution, right? What is route filtering, right? Let me write down here so that, okay. Now, the first unit that we are learning is routing fundamentals. Right? Here, we will learn what is route summarization. What is route summarization? What is route filtering? And what is route redistribution? Right? These are the things that you will be learning in this unit or in this first chapter, right? Now, with having the syllabus beside, let's start with the first thing that we have, which is, as you know, it is a route summarization. Route summarization. I would like to give an example to you guys before telling you what is a route summarization. Maybe this example will make you find out by yourself what is a summarization? So summarization, in the sense, let's assume, okay, let's assume two routers are connected to each other. Okay, basic. Two routers are connected to each other. Now, what is it connected to? Connected with an IP address of 1.1, 192.168.1.2. This is the interface through which they are connected. Sorry? Okay. So these are the interfaces through which they are connected. One end of the link is 192.168.1.1. Other end of the same link is 192.168.1.2. Fine. But on router 1, you have loopback 0 up to loopback 5. This is loopback 0, this is loopback 1, this is loopback 2, this is loopback 3, this is loopback 4, right? You have different networks on the loopback 10, 0, 0, 1. This is 10, 0, 1, 1. This is 10, 0, 2, 1. This is 10, 0, 3, 1. This is 10, 0, 4, 1. Excuse me, guys. Now, you can see that R1 has 5 loopback interfaces. 0, 1, 2, 3, 4, which is 5 loopback interfaces. Now, what does the routing table have of R1? Definitely, routing table, when you do a show IP route, it will show you the routing table. You all know about it, right? So, when you do a show IP route, it will show you all the networks which are connected to each other. I told you, all the networks that are connected to this router R1, right? I told you, that is the routing table. Let's write it here. The routing table of R1, 10.0.0.1, 10.0.1.
Sir,
Yeah.
what kind of protocol you run on that? Which protocol you run?
Still, I have not run any protocol on
Okay.
this router and router 2. Okay. We
Okay.
will run it. Okay. We will run it.
Okay, sir. The summarization for particular protocols, or it's
Summarization is not, particular for any protocol. It is a general topic.
okay.
Okay.
The
Okay,
kind
sir.
of basics, I think.
Yeah, kind of basic. I am just explaining you why do we need summarization. Okay.
Yes.
Okay, sir.
10.0.21, 10.0.31, 10.0.41. This is our routing table. 10.0.41. Apart from that, we have 192.168.1.1. This is the routing table of R1. Now, suppose, now what is the routing table of R2? Just only one thing connected here, 192.168.1. Network. Only one line. Here there are 6 lines of routing table. Now, you already know that 10 network, 10.0.0.1, 10.0.11, 10.0.21, 10.0.31, 10.0.41 these can also be represented as 10/0/16 in simple words. You can summarize it as /16. /16 means only these two. This is the network address. This is the host, right?
Yep.
/24 means these three will remain constant. Only this will change. /16 means these two will remain constant. This will change. Similarly, now you run a protocol, routing protocol on this. Let's say RIP, EIGRP. Now when we exchange the information with R2, you run a protocol, you have seen that, okay, the neighborship is established between, so that is good. So, once you run a protocol, the first thing what will happen is they will establish neighborship. After establishing neighborship, they will exchange their routing tables. Now, in the routing table of R1, you have so many. In the routing table of R2, you have only one network. So both will get exchanged. So here there will be one more line added, 192.168.1.0 network. Here you have another 6 lines added. Okay, 10 dot, another 6 lines added. All these will come here, right? Now, when you exchange the routing information, you're exchanging everything, right? Instead of all these networks, I can write all these networks in one line, /16, right? /16. This /16 also means the same networks. Instead of putting all these networks or exchanging all these networks of 6 lines, you can just exchange 10/0/0/16 in one line. Why? Why this summary is very important? Let me tell you. Now, this is the link between R1 and R2. Let's say it is capable of 10 Mbps, right? Now, in the first update, you are sending routing update packet. That is a message here. Okay. Routing update message. You are sending 10/0/0/1 as an update. Then you are sending 10/0/11. Then you are sending 10/0/21. Then you are sending an update of 10/0/31. Then you are sending 10/0/41. So basically, you are sending 6 packets to R2, right? Because you have 6 routing table packets, 6 networks you have. You have to send information about 6 networks to R2. Now let's assume the condition of R2. R2 has to process, the CPU inside R2 has to process 6 packets. One packet came in. Okay, I have to look into the packet. Oh, he is 10/0/0/1. Okay. Now I have to update my routing table. Okay, next packet came. This is 10/0/0/2. Okay, I have to look into the packet. I have to remove this envelope, look into it, and then update the routing table. Similarly, there are 6 packets. The CPU processing is high. The bandwidth needed is more, right? The bandwidth needed is more. The CPU processing is high. And lastly, the number of lines in the routing table is also more. What happens if the lines in the routing table is more? There is a CPU inside R2, right? There is a CPU. When a packet comes looking for, when a packets come to R2 and it says, I am looking for 10.0.20.0. Okay, 20.0 network. First, it will start with the first line. The CPU will start searching with the first line. Is 20.0 in the first line? Is 20.0 in the second line? Is 20.0? If 20.0 is in the last line, it will check all these lines and come to 20.0. So if there are 1,000 lines, imagine the CPU has to check all the 1,000 lines if 20.0 is in the last line, right? So more the number of lines in the routing table, CPU will take longer time to search that network, isn't it? Right? That is the reason when you send, instead of all these network, when you send a summarized update, it will be done in one single line. Only 2 lines in the routing table. When you send this as a packet, there is only one packet to process for the CPU. There is only one packet as a routing update. That is why the summarization is given a little importance. Any doubts on this topic?
So this will save the hardware performance of the router, CPU,
Exactly.
everything.
This will
Yeah.
save the performance of the router.
Understand, Rahul, understand.
So can we say this also cause latency?
That's right. So without summarization, there could be some latency. It will save latency as well. Right?
Rahul, what if R2 also have similar kind of loopback networks 10.05, 10.07, and then it
Same
make a
solution.
conflict, like it will also send 10/16 towards a R1.
Exactly. Exactly. Same solution. Summarize it and send it to R1. So that you're saving the bandwidth from R2 also, from R1 also. Basically, we are trying to keep this routing table to a minimum number of lines. Right? This routing table to a minimum number of lines. Here you see 6 number of lines. Here you just see 2.
So Rahul, basically on routers, the CPU is directly engaged in the routing table lookup, correct?
Correct, yes. It is responsible for creating routing tables.
Okay, but in layer 3 switch, does TCAM and both routing table, how is it engaged, like both together?
I didn't get you. What is the question?
And now consider there is a layer 3 switch, there
Okay.
is a core switch, and I have to do a routing lookup, and TCAM just does the MAC lookup only, not the routing lookup, only CPU is engaged?
You're talking about content accessible memory.
Yeah, right.
Right. Okay. So what happens is basically, before that, you have to learn one thing. So basically, this is a router. Right? Now, let me draw it this way. let me write a router as a box. Okay. Now, you know that there is a CPU without the brain. How will the router calculate routing table? How will it calculate distance and all that? It is not. So this is the router, okay, and it has ports here. What is this ports? This is the place where you connect your hardware, computers, switches, right? So that is why this is known as, you know it, it is known as data plane. Okay, sir, we know about it. So there is nothing surprising. Now, where is the control plane? Sir, control plane is this one. Now, both inside the router, both data plane and control plane are connected through a wire behind. Okay, that is known as a bus. Okay, also they call it as switch fabric. Right? You might have heard these terms.
Yes,
right?
yeah.
So they are connected with something like this. Okay. So any packet, let's say so this wire is connected to another router. Okay. This port is connected to a port of another router. There is an EIGRP. Guys, keep yourself on mute, please. So there is an EIGRP packet coming in. What does this packet have? To reach 10.0.1.0, you have to go to 192, for example. I'll write the bigger picture of routers here. Okay. This is 192.168. 192.168.1.1. This is 192.168.1.2. So if you want to reach, this is 10.0.1.0 network loopback. If you want to reach, you have to go to 192.168.1.1. There is an update coming from R1 saying my 10.0.1.0 is connected to me. If you want to reach it, you have to go via 1.1. Now it comes here. Now, what does the router has to do? Router knows that there are two kinds of packet or message in an envelope, right? One is the routing packet. The other one is the routed packet. What is the routed packet and routing packet? This is the routing packet, means it has the information of another network. Right? It is a routing protocol packet, which is coming from a routing protocol like EIGRP or RIP. It is coming as an update through EIGRP. What this port does, with the help of this bus, it sends to the control plane. Control plane reads this information. Oh, okay. To reach this network, I have to go to this one, right? To reach 10 dot network, I have to go to 192. Okay. Let me update the routing table. It will update the routing table. Simple, right? Very simple. It will update the routing table. Next packet comes. In routing table, what do you have in routing table? 10.0.1.0 go to 192.168.1.1. Now we already know, since this is 192.168.1.1, 1.2 is configured here, and here 1.1 is configured here, and this is GI 0/0. You already have directly connected networks, that is 192.168, because this is directly connected. 1.2. 1.2 is directly connected to you, and you will have GI 0/0 in the routing table. You would already have. Now, when a computer connected to this interface, computer wants to go to 1.2, then the data plane will directly, because this information will be downloaded to the forwarding plane here. Okay, forwarding information base. GI 0/0 go to 0/0, forward it from this interface for any 1.2 network. Right? It will directly forward the packet to 1.1. That is a routed packet. Means a computer is directly sending the data, or assume that this computer is trying to ping 1.2. It is not sending the information of any EIGRP or OSPF. It is directly sending the data. What is the data? You know that the ping, when you do a ping, you are sending an echo, right? Echo of 100 byte echo or 150 byte, whatever you said. You're just sending an echo. You want to send an echo, means you will refer to this table. What is this table? Forward information base. This is your routing information base, where the routing table is downloaded to the hardware. That is known as forwarding information base. If it is 1.2, directly go to GI 0/0. It will directly forward. That is a routed packet. This is a routed packet. This is a routing packet, whatever comes the information. So basically, now you should understand how the router, or when a control plane is involved in a router, or when is a TCAM coming into action, right? When a data plane is involved in a router, right? Are you clear on that?
Yes, Rahul. So see, basically now routing packet, now our EIGRP is sending, now in this case, it's a PC connected to PC in the same router. It is working as a routed packet, correct?
Yes.
So my RIP is the routing table that is being downloaded to the data plane,
Correct.
or correct?
Yes.
Okay. And the fib is used as a reference to route through the data plane, correct?
Now, simple, just to remember this, just assume that, see, whenever a packet comes here, every time it has to go to the control plane, then the control plane has to send information to the data plane, then data plane will see. When it goes to the control plane sees the information, it tells you go out of GI 0/3. Then data plane agrees control plane and goes to GI 0/3. So going to control plane and they taking the advice, then coming back to the control plane, then from control plane deciding the port and sending out the information. This is actually taking some time.
Correct.
Right? The router, this is actually taking some time. So what they do, they download this routing table into the data plane.
Okay.
So that whenever the information comes here, whichever information does not need any CPU usage or any brain to fill up the routing table. For handling the routed packets, if I want to go to, for example, there is a 1.50 network connected here, and forwarding information base says, if anything comes for 1.50, just forward it out of G0/3. No need to update the routing table. This is a routed packet. Comes here, directly it will forward. Whatever information comes here, directly it will forward out of this interface. Simple, without even consulting the control plane. So the process is gotten faster, right?
Right. So like how often does it gets downloaded? Like
the control plane, every time it is updated.
Okay.
So right, there is no update in the control plane, right? So it is not downloaded. So whenever there is an update in the control plane or routing information base, it is downloaded as forwarding information base.
Okay.
In-
Okay. Got it.
Right? So basically, you have to know about these planes. Control plane has a CPU. Data plane, it does not have any brain. It is just used to forward the data. You come from my left hand, I have to forward it to you to my right hand. Similarly, the ports are your hands, kind of, right?
Good.
They are just used for forwarding.
Yeah.
Right?
Yeah. So IPsec comes into this picture, right? Like, I mean, the Cisco proprietary thing comes into this picture. The CEF thing.
CEF, yes.
Okay.
CEF is one such technology where this is why we use CEF to make the process faster, right? To make the process of forwarding faster.
Got
So
it.
that is about. So guys, no questions still here. Are you clear?
Yeah, clear, Rahul. Small question. A small doubt.
Sure.
Sir, is
So,
it
but
big or if
sorry, can I?
Yeah. Your name, please.
Yeah.
Sumit Kashyap?
My name is Sharath.
Yes, Sharad. Go ahead.
Sharath. So, when the summarized route is there in the router, and also there is a longest match preferred route is there. So it's almost take with the longest match submit, right?
Right.
Okay, so I just want to know. So a summarized route will be if there is no longest match, then only the summarized route will be used, right?
Exactly. That is our next topic.
Rahul, if R1 and R2 both are using that summarization, so if R1 is also advertising 10/16 and R2 is also advertising 10/16, so will it not be a conflict?
They will not advertise 10/16 because it is connected to both of them, right? It is in the connected route. So basically what you're asking is, I'll tell you. So sorry, I didn't get your name.
Lakshya.
Okay, Lakshya. Thanks for this question, Lakshya. So this is, are you saying that this is 10/16? For example,
No,
this.
like
Huh?
we had 4 loopbacks in R1 and 4 loopbacks in R2, right? So
Correct. Okay.
so R1 advertise it makes a summary at that 10/16, right? And R2 also does 10/16. So
No. So when you know that, right? When you know that there is 10 IP address already used in this router. For example, in my company, I have used 10.IP address for all the printers connected to this routers, right? I will not use the same 10 dot network here. I will use 11 network here, right? So I will advertise 11.00/16 from this side, and from this side, I will advertise 10.00/16. Right, Laksh?
yeah, but what if I do 10.05, 10.06, 10.07 in R2? So because it is a different network only, right? But
Exactly. So yes, I'll come to that as well. So Laksh is saying that here we can advertise 10.000/16, right? But here also, what if I choose? So this is ending at 10.020. Let's say 10.031, 10.021, 10.031. Now here I'm taking 10.041, 10.051, 10.061, etc. So now at this time, when you summarize, you have to summarize on both sides as 10.000/16, right? Now, as an administrator, because the router does not do this, right? The router does auto summary. That is according to the class. Whenever an administrator does this one, summarization, it is known as manual summarization, right? As an administrator, I would not do a 10/16 here also and here also. I would give a different summary address, right? Right, Laksh? So if you are doing it from 0 to 3 here, I would say 10/030/16, right? A different summary address. Or let's say this is /19.
But like auto sum, what will be the auto summary from R1 and R2? It will be
Auto summary will be this one.
so this will cause a conflict, right? R1 and R2.
Exactly. It will cause a conflict. Both sides will have the same networks. It will cause a conflict.
It won't work.
Yes, it won't work. So that is the reason almost in every routing protocols, we give a command known as no auto summary. If you would have seen that somewhere.
Yeah.
That is the reason we always give no auto summary command on most of the routing protocols, which does summarization by default. Okay.
Yeah.
Now, anybody has any questions?
So, Rahul,
Yes.
what is the command to check data plane and fib and rib? Rib is basically a route, show IP route.
Yes, that's right.
चलो ना ऊपर फिर अरेंद्र फिर जाओ आप ऊपर.
Guys, please be on mute.
So for fib, are we using Ceph, show IP Ceph or something else?
If you are using a Ceph, you can use a show IP Ceph.
Okay.
Right.
So if it is a non-Cisco device like HP or Juniper, is there some technology or some specific
We'll come to that. So I wanted to discuss. We have a different portion for Ceph as well.
Okay.
All right. So yeah, moving on. So we had the topics here. We had written summarization. So we learned about the route summarization, right? Why do we need summarization? What is the effect of summarization? How does it save our network, right? Now, we learn, I'll come to this one because this has more time. We'll talk about route redistribution. One second, guys. Okay, route redistribution. Now, let's talk about route redistribution. I think you guys would have known about redistribution, isn't it?
Yes,
Are you
sir.
aware of the concept of redistribution?
Yes, sir.
Not fully. No.
Okay, no problem. So let me explain that. So here I am running RIP and I have all the 10 networks, 10.0.0.0, 10.0.1.0, 10.0.2.0 connected here. I have 11.0.1.0, 11.0.2.0 connected here. Now, only problem is routers are connected between each other. The link is fine. Everything is doing good. But only thing is these loopbacks, this loopback is in RIP. Right? This router is running RIP and this router is running EIGRP. Right? Now, you can see that there are two protocols. For example, in layman terms, if you want me to talk in layman terms, it is like two different languages. Two different languages. Either French or Spanish, right? He is talking in French and he is talking in Spanish. So both cannot understand each other's language. Either both of them have to know both languages. Only then the information is able to pass from here to here. If both the routers do not know both the languages, then it is difficult to pass the information. What do I mean? Means you have to run both the protocols, both EIGRP. This router and this router should be running both EIGRP and RIP so that they can translate the information from one language to another. This translation is known as route redistribution, right? We will talk about the lab and terms in redistribution whenever we go deep in that protocol that we are learning. Okay, but for now, I'll just explain you the concept of redistribution. Now, whenever these two are connected, in EIGRP, they have become EIGRP neighbors, but these are not the loopbacks, but these are the networks which are learned through RIP, and these are coming from R5 here. R5 is sending 10.020, 10.010 to them in RIP, but these two are running EIGR. Now I have to give this 10.010, 10.020 to this guy also because he has to know. Because there are computers connected here. They would want to connect to 10.020, 10.010, right? What do? I use the concept called route redistribution. In route redistribution, first thing that you have to remember, go to the destination protocol. What is a destination protocol, guys? Destination protocol means to the protocol that you want to translate. If I want to translate in EIGRP, then I will go to router EIGRP. I will go to EIGRP and then say redistribute RIP. Then what happens? All the RIP will be translated to the EIGRP. If you want to translate it to RIP, then first you have to go to the protocol RIP, then redistribute EIGRP. So whatever the destination protocol is, that is, wherever you want to translate it, you have to get inside that protocol and then redistribute the source. Okay.
Sorry. So that means we need to log into each of the routers and perform those commands.
Correct. No, I mean to say that whenever you are in this router, right? Whenever you are in this router, now you have a scenario where you have to redistribute or translate from RIP to EIGRP. Now, what do? In this router, I go to router EIGRP. Why? Because I am translating from RIP to EIGRP. So what is the destination protocol here?
EIGRP.
That's right. So I will get into router EIGRP on this router. And then use a small command or simple command. Just redistribute RIP. Whatever information in the routing table that you have for RIP, all the networks will be translated to EIGRP, right? That is the mechanism of this particular redistribute command. This is known as route redistribution. Now R2 is running RIP between these two routers, imagine. Now whatever the EIGRP information is coming here, it will be in the routing table. You agree with me, right? It will be in the routing table. Whatever has come from RIP from here, it will also be in the routing table, same routing table. RIP is denoted as R. The routes coming from EIGRP will be denoted as D. Only difference between them. So you have many lines in the routing table, many networks, right? How do you differentiate between different protocols? Simple. RIP will be represented as R. EIGRP will be denoted as D, and OSPF will be written as O. Means if I write any network 10.0.0.1 learned from 192.168.1.2, if I write an R here, means I've got this network to me from 192.168. Let me make it as 1 here. Okay. I've got this from 1.1. That is fine. I've got the network 10.0.0.1. Okay. But through what protocol this is coming to me? Through what protocol? It is coming through to me via RIP. If I write D here and write the same line, the router will understand that, okay, this is coming to me via EIGRP. So when the administrator says show IP route only of EIGRP, then I have to show this route to him, right? So it will differentiate whatever the routes we have got from whatever protocol. As simple as that. That is the concept of route redistribution. Now you might ask me, sir, why this redistribution concept came in? What was there a need? Simple. First, they
Communicate different protocols.
Sorry?
Communicate between the different multiple protocols, right?
Company acquisitions and maybe something like that, right?
Right.
Communication for them. Oh.
First,
Yeah,
they
it's a
deployed
communication.
RIP. Right. First, in this world, so when the routing protocol was developing, first maybe RIP would have been developed, right? So many people started using RIP in their business, corporate business. Then they discovered EIGRP, but nobody wanted to go because they had to change this information to EIGRP. But they said, in RIP, you can only reach up to 15 routers. 16th will be marked as unreachable in RIP. In EIGRP, there is nothing like that. Even if you have 250 routers in your network, you can still communicate. Then many companies thought, oh my God, this is a good option. Why don't I implement EIGRP then? So then they were thinking of removing all the networks that was existing. It is a tedious, difficult job. I have to remove all the RIP and configure EIGRP afresh. Then the institution said, or the organization, standard organization said, no, you don't have to do that. There is a concept of redistribution. You can use that. Then till here they have configured RIP. Then they configured EIGRP from extra routers, whatever they bought in their company. as their company grew, they configured EIGRP on all of them. From here to here, they used redistribution. As simple as that. Okay?
Yes, Rahul. So see the way you told, we route to the destination protocol, it's a single point redistribution, correct?
Exactly.
Okay. Okay.
But the router should know both the languages. Suppose you are the person who is speaking to both English guy and Hindi guy. You should know both the languages to translate from one to the other, right? Similarly, the router also should be running both the protocols like EIGRP and RIP. Only then it will be able to redistribute from one protocol to the other, right?
Okay. Yeah, got it. Thanks.
Any questions still here, guys?
The router also has to support all the protocols, right? Then only it's possible.
Exactly. The router also has to support all the protocols.
Yeah, okay.
Sir, redistribution needs to be done on the connected routers only, or it needs to be done on all the routers?
Only on the connected routers. So whenever you see, now I told you, right? So this is RIP, right? Now these routers are connected to each other, right? This is your enterprise network, okay? Office, company, enterprise network. Now, here you're running RIP. All these routers running RIP, 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 RIP. We'll come back to this. All this are running EIGRP. EIGRP, 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 EIGRP. Now, this is acting as a border route, right? This is a border route. This has to run RIP also, EIGRP also. So all the information coming from RIP will be here. Do you agree? Whenever you translate it to EIGRP, all the RIP information will be translated to EIGRP. Only redistribution on one router would be enough, right? Similarly, if RIP wants to know the other part of the world, the redistribution on the other side also is important. Did you get it?
Yes, sir. Got it. Thanks.
Yes. So
Is that the
Rahul,
gateway router?
Sorry?
Is that the gateway router? The one at the middle?
So it can be not necessary that it is a gateway. It is the border router in the sense which is according to your company topology, according to your enterprise topology, this router is connecting to both the protocols. It is in the middle of both the protocols. So this will be selected as the border router and the redistribution will be done here.
Now
Right?
redistribution needs to be done like from RIP to EIGRP and EIGRP to RIP, right?
Correct.
Both.
Yes. It should be done both the ways.
so,
right?
So Rahul, in general, if you look at the design, right, are we doing this at core layer or distribution layer? Like basically it should be on core layer, right? I mean, that redistribution that should happen in an enterprise.
that is up to you. So basically, core layer, distribution layer, it is how you plan, right? So whenever you have any router, like for example, you have a normal router here, but you bring in another router which is running OSPF. even on this normal router, you have to do a redistribution, right?
Yes.
Depends on how you use it.
Okay, but usually in orgs they do in core, right? I mean, logically.
Yes, that is right. So usually we plan on core routers. So guys,
Okay.
don't worry about the core distribution and access. We'll talk about it. If somebody doesn't know, if you all know about it, then that's good. So till now, do we have any doubts? Did you get the concept? Was it clear?
Yes,
Yes.
Rahul. So
Yes, Rahul.
we can say, right, static to the dynamic protocol also we can use this distribution, right?
Correct.
Yeah.
So till now, till today, what we have seen is, I mean, till in this class, we know that routers are connected to each other, right?
Mhm.
In this class, whatever we have learned is routers are connected to each other and will be connected to each other. Having different networks on the routers is not good enough, right? If the computers are connected here, and this is the IP address of a server here, 10.0.0.10.0.20. What is the server? Let's say you're a Flipkart company, Amazon company. This server is giving you, the shoes rate, the shoes price, or maybe some sports equipment price that you can buy online. This is the server connected to this router. This computer wants to access those servers, but unless it knows where is 10 dot network, how can it go to 10 dot network? It cannot go. There is 192.168, 1.1 here, 1.2 here. Right? This computer is 11 dot network connected. Unless it knows where is 10 dot network, it cannot go. So for that, we need to exchange routing information. In the olden world, this caused to introduce or discover something known as routing. First, they introduced static routing. Then, as and when the number of routers increased, the administrators gave up. I cannot do this. So they introduced something known as dynamic routing. In dynamic routing, they decided, see, let there be a procedure. First, let the two routers discover each other and become neighbor as a first part. Then let they exchange the routing table. That is the complete two process of dynamic routing. Then in dynamic routing, first came RIP. I mean, generally talking, EIGRP. Whatever the protocols are existing now, I'm talking about them. Then came OSPF. Why there are three protocols? Why can't there be one? Because one provides more advantage than the other. Then the world shifts to the next one. Just like how you have an update on your phones, like Apple iOS, sends you an update, or Android OS gives an update. You try to update it, right? Try to use new features. Similarly, the first protocol had some disadvantages, which was covered by next protocol. The next protocol had some disadvantage, was covered by the next protocol, like that. Now, since there are many protocols used, then arose a concept known as redistribution. So this is all a circle. One created the invention of the other. This is all kind of a circle. When you start thinking why this was discovered, why this was, introduced, you will get the answer of everything. So if you remember them as, questioning yourself why this might have been discovered, you will get the answer and you will have it in your memory for a long time, right? So any concept that you read, I would suggest you guys to, go through it in such a way that, you're just trying to question yourself, or, trying to, dig more on it, questioning every simple technique or mechanism that they have found out will actually improvise your, memory. So network as a networking subject, that it is quite hard to remember the port numbers, remember the protocol numbers. But if you go about thinking in such a way, I think it might be easier. So these are the concepts that we discovered, that we talked about today, right? Apart from that, I also told you that we discussed about route summarization and route redistribution, right? When you had two routers here, we saw how the redistribution came into picture. Also, when the routers kept on growing, 10.0.0.0/16, when did they decide to use the summarized route? Maybe there were many 10.0.1.1 like that. They had 10.0.2.1 and up to they had 10.0.99.1. So this would introduce 99 lines on the routing table. So let me summarize it. This was the maybe the birth of summarization, right? We spoke about summarization also, redistribution also. Maybe in the next class, we can talk about route filtering. What is route filtering? You know what is a filter, right? How to filter so and so networks, how to filter, how to select so and so network. That is what is known as route filtering. In depth, we can learn it tomorrow. But usually, apart from the syllabus, guys, apart from the training, I am thinking of, having the class for like 1.5 to 2 hours. Because I think that is the 1.5 or 2 hours would be the more, is the maximum time that everybody will be able to concentrate. Above that, it'll not, you'll not be able to focus, I thought. But let me know your opinions. Are you good with having class more than 2 hours, or like 1.5 hour to 2 hours is good? Let me know.
Yeah, 1.5 hour, 2 hours is
Yeah,
good.
1.5
Yeah,
hours
that
is
is
good.
that will be fine now.
1.5 2 hours.
Because we can't go focus after 2 hours, I'm damn sure.
Yes,
And we are working in
exactly.
shifts. That's
And we
another thing.
have duty
Yeah,
times also.
somebody working also, it's correct. Yeah.